Okay, so for today's call, the agenda is that we will be completing the pending item that was doing the code analysis of brbot.exe, and we will continue with that. So last time we were able to decode the data of brbconfig.temp without kind of using the code analysis. But today, kind of, I will be showcasing the code analysis for that. And thing is, I won't be using Ollie debug because Ollie debug, what we found is like the 64 version is still not working. 64-bit version of Ollie debug is not working, and so I will be using the x64 debug today to kind of show the code analysis. So let's go to that. Okay, just a minute. Like when you are like kind of trying to turn on the VM and it's not turning on. So one of the technique that I use is like you go to the VM folder, and in that what will happen, you will find some file like .lck, that means like lock. So what you need to do is like you just delete that lock file and the VM will start running again. Okay. So okay. So now what I will be going to do is, since we found that we were not able to kind of load the BRB bot in Ollie debug, I will be loading that in the x64 debug, and let's go to that. And there are a lot of interesting things that we will see. Like today, we will also start a web server, because you might recall that BRB bot was actually trying to connect to ads.php. And so what we will do is like we will start a web server and kind of put a fake ads.php, and we'll just monitor like what kind of are we able to control the exe using that fake web server. Okay. So let's directly go to the x64 debug. And the other thing is, if suppose I load the if I load the file, if I load the brbot.exe inside this x32 debug. So let's do that. Stop brbot. So you can see that in this panel, in the bottom panel, you can see that it's written use x64 debug to x64 dbg to debug this file. So thing is, x32 already it detected that it's a 64-bit version of malware, so it won't be loading in this one. So it's suggesting us to kind of use the x64 debug. So now I will be using that, and let's do that. And after before that, before telling you that, guys, okay, I'm loading this malware in this debugger, what thing was that we did last time was, we have to kind of make sure that this file is existing before we do the static analysis, because thing is, the malware will be trying to read this file, and if this file is not there, there won't be any file that the malware will be reading. So make sure that brb config that you execute this malware, and then kind of just wait for 1 minute just to let this file get created, and then you kind of load the malware in x64 debug. So I'm just again starting the x64 debug, and let's load this brbot.exe. Okay. And the brbot.exe has been loaded in the x64 debug. And thing is, I'll just showcase you first of all, like what are the kind of, since it's a new tool, um, uh, I assume for both of you. So thing is, I'll just showcase the what's the window and all. So if you see this section over here, it's actually tells us the kind of like registry value of the CPU. Like there is a registry called RAX, RBX, RCX, RDX. So this all things will be getting clear when I will like starting the assembly language primer. And kind of just for now, you just remember that in the in a x60 in a 64-bit CPU, the registered are named as RAX. Then if you recall, in 32-bit the name of the register was EAX, but over here it's RAX. So this is the pan of the CPU pan. Then this is the stack that you see, and then there is something new over here. The new thing is like command menu. So x64 comes with certain by default commands. So suppose I want to set a breakpoint, I can do that by executing the command over here. So there is specific command to do that. And before that, you see the software is paused. So it seems okay. Yeah, software paused at this point. So I just want to like just know from you guys, like can you tell me like how the software breakpoints actually works? And any guesses from both of you?
Yeah, Pragyan, a software breakpoint works in such a way that when that particular command is executed, right before that command is executed, we stop there.
Yeah, so thing is like what happens, like suppose you do a right click and set the breakpoint. So how does the debugger knows that I have to stop at that breakpoint? I Because there might be a situation where, okay, you might guess that maybe it is recording the offset value that there might like, as I'm highlighting it over here, it might record that and kind of just see, okay, when the instruction pointer is going to be in that one, and kind of like stop that moment. But actually it doesn't work like that. So the thing is, how it actually works is like, what it does is like, if you see over here in this span over here, that it is written pause and then int3 breakpoint. Okay, so what it does is that most of the time, what it does, if you see the code over here, cc. Okay, so cc is a assembly language instruction which kind of cc is a binary which actually means int3. Okay, so what happens when you like I just want to let you know guys that when you do a software breakpoint, what it does is like, suppose I have some functions over here and I want to breakpoint over here, I want to put a breakpoint over here. So internally what the debugger will do, it will append a cc instruction in front of this XOR. Okay, and what happened when the pointer goes to this CC, the debugger stops at that moment, because it's a kind of an interrupt. It tells the debugger to stop the process. Okay, so what it does is actually it injects a assembly code, that is CC, in the line that you want to do a breakpoint. So what will happen, like for this ZOR RAD. So the binary is 4533 CO. So internally what it will do, it will put a CC over here so that it will get interrupted. Okay, so this is how the software breakpoint works. And thing is, if you guys want, maybe in the later course, if we see the Python coding, so I will just showcase you guys like, okay, how can you code your own debugger, and how can you put a breakpoint, how can you add a functionality to your script, so that whenever I want, I put a breakpoint, so that script will do add a breakpoint for you. So what it will do, you write a script which will work like a debugger. Like, you don't have to depend on x64 debugger, all you debug IDA Pro. You can code your own using just Python script, and then you can add a functionality of like, okay, when you click on add breakpoint, the script will kind of add CC in the code, and the breakpoint will work. So I hope this technique is clear to both of you.
Yeah, Pragyan, just one question.
Yeah,
So this CC thing, which gets appended in the beginning of the statement,
yeah.
that's happening only for software breakpoint or all three, software, hardware, and memory?
No, it happens only for the software breakpoint. Yeah.
Okay. And one more thing, in the offset values, we can see that they begin from 007. So we can say that this is CPU space, right?
Uh, you mean the left column or the right one? Uh,
Not the offset, sorry, the leftmost column,
okay.
000, like 4 times 0 and then 7.
Yeah,
So
yeah, yeah.
this represents kernel space, right?
Yeah, so it's actually the RAM memory offset. Okay,
Okay.
where kind of in the where the this offset, this code is existing right now. Yeah.
Okay, Prabhu.
Yeah. So because thing is like if you see the stack values and all,
Pragyan,
yeah,
uh,
yep,
like
Sanjay.
you said, once we set this breakpoint, it will put CC in front of the code
Yes, yeah,
and it will get interrupted. So
yeah.
in that case, will it get interrupted and then stopped at that point, or else it will just exclude that line and move to other line?
No, so what will happen when as soon as like you because debugger has injected a CC in a hidden mode, I can't see it won't show that thing over here. So what will happen
Okay,
as soon as the interrupt is there, the process will actually stop at that moment of time. In the next
okay.
line, so CC will be executed, and the next line it will be
Mm-hmm.
stopping. So till the time you don't press go, it won't run from there.
Oh, okay.
Yeah, and
I understand.
that yeah, and that's why kind of sometimes a malware what it does, like suppose they want to like know that the malware is getting debugged. So what they will do is actually what will do is they will take a hash value of quick like maybe in 5 or 10 seconds one of the function might be taking hash value of their own code. Okay, so what will happen, like suppose the debugger has injected a CC, so the hash value will change, and kind of the malware will know that someone is trying to analyze this my code, and it will kind of exit from there. So that is why like kind of software breakpoint are sometimes very tricky to implement, because if the malware is sophisticated, it can know very easily that its code was kind of getting analyzed. Okay, so let's go further and just let me see. Okay, now X64 actually, if you see that it has already highlighted the entry point over here. So what happens is like there is a when you see the portable executable. So any exe we tells that as a portable executable. So actually there is a kind of entry which tells like okay, what's the starting point of this process. Okay, so thing is we will see that in much more detail later, like how can you like maybe parse the PE header and kind of see what is the entry point for that process. But thing is the debugger is doing that for you, and it is parsing the PE header, and then it is knowing what's the entry point, and it is stopping at that entry point for you. Okay, so it kind of pause at that entry point. And thing is now the other thing is when you load this malware in your computer, might be this offset that is highlighted over here, 07FF7D8 EB, something like that. So it might be different for you guys. Okay, when you load that, so when you load the same thing in your X64 digger, the offset might be different. Okay, so I just want to know, can you guess why that case happens? Yeah, any
Because it
guess?
depends on the RAM space only. So
um
it'll vary depending on the device.
no, actually you, if you might recall, I talked in earlier classes about ASLR. So any guess, if you recall, if you're able to recall that what's ASLR means?
I'm not able to recall from
Okay. So thing is ASLR, as I told, it means address space layout randomization. So what happened? It's a functionality given by the Windows operating system. So what it does is like whenever you kind of load whenever any process run, so the memory space is actually randomized for that. So you load the process, and the offset value will be kind of random. You can't guess that what will be the entry point in the memory, in the RAM memory for this process. So thing is that's the reason actually when you load the same exe in your computer, the this id, this offset will be different. So the reason why this Windows has actually in like kind of introduced this ASLR thing is like in earlier days when kind of exploit writer used to write exploits for any software. So they, what they do is like they execute the process. Suppose I want to make an exploit for VLC, so I'll execute the process VLC in my computer, and I will know, okay, what's the offset value where I can kind of inject my malicious code and like kind of hack the VLC and get a remote connection of the computer. So I will know the offset value. So what I will do is I will write an exploit, and it will go to suppose any of the computer, and it will see if VLC is running, and it will inject the code at that particular offset. Okay, and I will be getting a remote connection to the computer. So to evade that, Windows has actually kind of introduced this ASLR, so that I won't be able to predict that what the offset value where this instruction will be there in their RAM memory, in the suppose I want to attack someone's computer, so I won't be able to guess the memory offset for this instruction in his RAM memory layout. Okay, just because of the ASLR. Okay, and that's how my exploit will actually fail. It will work maybe only for me in the lab environment, but it won't work in the real life. Okay, so that's how the ASLR works. So thing is, this all thing are discussed in much more detail, like when you develop an exploit, when you develop an exploit for any software. So that's where ASLR, and there are other protection like DEP, data execution prevention. There are a lot of other security controls, you are introduced, like what are the security control introduced by Windows and how to evade those. So there are kind of techniques how you can evade this ASLR, but that's more from the exploit writing thing. Okay, so let's go further and kind of let's see what the things that x64 have to offer. Okay, and now in the debug menu, if I see that there are multiple options, if you'll see, like you can kind of suppose I want to run this malware, I can just click over here, run, and it has shortcut called F9. And then there are other functions, like suppose I want to execute only one instruction, I will just do step into, or maybe F7. So using the GUI to do the step into or using the run will be kind of very difficult. So normally it's preferred to kind of remember the code for that, like F7, and kind of the process will like kind of you will like stepping into the assembly language one by one. Okay, so there are multiple things like that, and even like there are some instruction like execute till return. So what happens, suppose you are inside a function and you want to go now to the to your original code where this function was called. So suppose you are inside the function, you just execute till return, and kind of it will run till the function exit and go to the user code again. Okay, so there are different menus actually you can see from the debug menu, and we'll be using this all kind of features while analyzing this BRB bot. Okay, so let's go for So now the task over here, if you can recall, like we have to kind of see where this BRB bot is actually reading the BRB config.temp file. So as we did in the srvcp.exe, we'll be following the same process. But since this debugger is kind of a new and it's x64 debug, if you can recall in the Oli debug, just to see, okay, where the file is being read, what we did was like we just pressed Control plus N, and we got the names window, and we were able to we were just searching for fopen command function, where the function is getting called and kind of like opening that file for reading. So over here, thing is we will be doing the same steps, but since Control plus N feature is not over not in this x64 debug, so we will be using some other techniques, like how we can achieve the same technique in x64 debug. Okay, so let's go and kind of see where we can find, okay, what are the functions that this x64 debugger is like kind of using. Okay, so let's do that. Okay, so now what will happen is like as you can as if you recall, like I'll just showcase you guys that if I go to P Studio and let's try to load the brbot.exe, and let's see the imports table. Yeah, So if you see in the import table in P Studio, you know now that this software BRB bot is actually having the functionality of, like, it has the function that it is using a function called read file. Okay, so thing is, maybe if we guess, okay, that maybe this BRB bot is trying to use this function to read the file brbconfig.temp. So now from here we know, okay, to read a file, the software, this malware is actually maybe calling the read file from kernel32.dll. So what we will do is, like, since this x64 debugger doesn't has the functionality of like just pressing Control plus N and kind of getting the names of functions like read file and other functions. So what we'll do is we will set a breakpoint on read file. Okay. So now you guys might be thinking like, okay, I am not seeing any code over here where I am seeing, okay, the read file has been called, but then how I can set a breakpoint? Okay, I can't do, like, suppose I can't do a right click and do a breakpoint over here, because since I don't see a read file function getting called over here. So how can I do that? Okay, so the easy way that you can achieve that in x64 debug is by using the commands window. Okay, so there's a specific command to kind of set the breakpoint in the read file. So what I will do is, let's do that. So I will do set bpx, that means set breakpoint, and then I will just write the name of the function, read file. I just need to know the spelling, read file. Okay, okay, and then I'll just press enter. So breakpoint has been set. If you can see in the status window, that breakpoint has been set over here. Okay, so now what we'll do is kind of we will just
Again, how to see that breakpoint? We
please,
have set it. We have set it right over here. May I know how can we see it? How to
okay,
see the breakpoint?
yeah. So what I will do is kind of I will now run the malware, and we will see that the malware actually stopped at that breakpoint, and in that line we will see that it is written actually that that the malware is actually about to call the read file. Okay, so that's how we'll know, okay, the malware. So this is a point where the malware is actually trying to kind of trying to read the file. And also thing is, you can see the offset value is already shown to you over here, that 000007FF9, something like that. So actually what happens is, like, x64 debugger actually analyzed the code and found, okay, where the read file breakpoint window is the function is called, the malware is calling the breakpoint function, and then it actually found, okay, at this offset location the malware is trying to import the read file function. And so what we'll do is now we'll just run the malware and then kind of just see if the breakpoint was really useful to us, if the malware, if this x64 debugger was actually able to kind of stop at the calling of the read file. Okay, so I hope I answer your question, Sandeep, right?
Yeah, Pragyan.
Okay, great. So let's see that. And apart from that, before doing that, I will just showcase you guys that if you go to the breakpoint window, you see that, okay, one of the breakpoint has been set over here, the kernel32.dll.read file. Okay, and the offset value is something over here. And you guys might also be happy that this is a software breakpoint, and if you have also set a hardware breakpoint, it will be shown over here, and also the memory breakpoint will be shown over here. So these two things we will be seeing later, how we can kind of implement the hardware breakpoint and memory breakpoint. But for now, we will be kind of doing the software breakpoint. Okay, and the other thing I just want to ask you guys, like, can you guess, like, how this memory breakpoint works? Any guess for that?
The code stops when that, as in, I'm guessing similar to software breakpoint, as CC was appended,
Yeah.
something is appended uh, in the statement, and that when that statement is executed in the kernel space, it's stopped.
Okay, so thing is, like, if what happened, the only reason this hardware and memory breakpoint was introduced is actually kind of to not let the malware know that we are analyzing it, this malware. Okay, so thing is, if we just give me, so if we inject the code actually in the code, if you inject the CC, suppose, or any other code in the malware code itself, so what will happen? The malware might know using the hash value. So we don't want to do that. Okay, we don't want to kind of do that and kind of let the malware know that we are analyzing it. So that's why the memory and hardware breakpoints are there. So what normally happens is kind of what happen is when the process is loaded in the RAM memory. So you might recall from the operating system concept that the kind of there are slots value that are in the RAM memory, like kind of a pages, if you can recall. Okay, so what happened is like we set a breakpoint on that page, that suppose that page is about to be, that page, that like kind of a slot in that memory is about to be read, we set a breakpoint. So that's how the malware actually doesn't know that a breakpoint has been set. Okay, so these all things will be getting clear actually when I will be like maybe implementing the hardware and memory breakpoint. Okay, so just want to give an idea like how the memory breakpoint might work and hardware breakpoint might work. Okay, so let's go back to the software breakpoint, and now what I will do is kind of I will start this process. So let's do that. So this is the actually just give me a minute. Yeah, guys. So thing is, now to run this malware, since it is already in pause state, you can either click this arrow key, or you can just go to the debug menu and maybe click over here or press the F9 value. Okay, so let's click it over here, and you can see that the breakpoint was successful at this offset. If you see that it is, the code is actually, the malware is actually trying to kind of call this read file function, and kind of maybe it is calling this function to kind of maybe read our brb config.temp. So the other thing that kind of I just want to so tell you guys that okay, in Ollie debug it was very easy, kind of you did the control plus n and kind of see what were the offset where the read file was called. But I want to inform you guys that those techniques might, the malware might fool you that okay, you did control plus n, the malware is actually calling the read file, but it's not showing in the control plus n window in Ollie debug. Okay, so malware can actually fool most of the debugger to not let them know where those functions are getting called. Okay, so for that malware srvcp.exe it actually worked, but maybe for other malware, maybe for this one or some other thing is like it won't work. So the one of the foolproof technique by which you can make sure that I am actually doing a breakpoint on all read files is actually kind of you load that in x64 debugger, and then kind of just execute the command set bpx and just give the name of the function. Okay, don't kind of do a control n and kind of see where those functions are called. Okay, because as I told, that malware can fool the debugger and not let you see the entry where it's actually calling that read file. Okay, so the foolproof technique is actually to kind of set the command set bpx and name of the function. Okay, so let's go further. And now guys, I want to know, okay, how this read file works, what are the parameters that goes to that. So these are techniques, these are things that I want to know. Okay, so how can I know that? So any guesses from you guys, how can I know like okay, what's the parameter that goes into this function and kind of what the returning value of that? Any guesses from you, how can I know that? And the hint is like I won't be using a debugger. Okay, how can I know about any functions? Like I have seen it for first time, how can I know that? Like what's the parameter that goes into that and that the returning value of that?
from the register.
um, uh, from the register, it's actually correct, but I'm telling you like okay, you don't have to use the debugger. Okay, but you just have to know about that read file, or maybe what things it accepts and kind of where it returns the value. Okay, so the thing is, you actually, whenever you see any function that you are seeing it for first time and you don't know kind of like what that function is accepting or returning, so always go to the Microsoft MSDN document. Okay, let's see if I can go to that MSDN read file. Just let's see if, yeah, okay. kernel 32. So this is how you actually kind of know about that function, that you just do a Google search and go to the Microsoft documentation, and you can see whole lot of functions that over here. Okay, there are several functions over here. Just go to the read file function and see like, okay, what are the parameter it is accepting over here, like handle to the file. Okay, now you know that, okay, the name of the function won't be loaded in the stack, or name of the file that this read file is about to kind of read will not be passed to the stack. You just know beforehand, you kind of analyze that in the debugger, that the handle of that will be loaded, not the actual file name. Because if you recall, in the fopen, we were actually seeing the name of the file. Okay, so fopen actually take the string file path as an argument, but here the handle file will be sent to the read file, and then there are a lot of other kind of argument that goes into that. Okay, and you can read about that more in detail in this MSDN document. So guys, I just want to let you know that whenever in your career you are like kind of analyzing any function and you don't know what that does, so always go to the MSDN document and kind of know about that, like what are the parameter it goes and where it returns the value. And now the other thing that's a very important thing that I want to showcase you guys, that if you recall, in when I was kind of when we were kind of analyzing the srvcp.exe, the parameters that were going into the function were actually loaded in the stack memory, if you are recalling that. Okay, if you're able to recall that. So thing is, the only difference when we analyze a 64-bit malware or 64-bit process, the parameters that goes into the function that is about to be passed to the functions are not loaded in the stack, but it's actually loaded in the register value. Okay, so if you see over here, so these are the parameters that will be going to the uh, to the function. Okay, so this is where you see that these are the values that are going to this function. Okay, so uh, thing is, whenever you are analyzing any 64-bit malware and you are not seeing the parameter that are passed to a function in the stack memory, always remember that, okay, I am analyzing a 64-bit memory, 64-bit process, and the arguments to that function won't be ever loaded in the stack, but it will be always loaded in the uh, register value. Okay, that's the difference. That's a major difference in a x64 debugger process. Okay, and now if you see that I am in the breakpoint of read file, but kind of the module that is showing over here is kernel32.dll. I am not in the process malware process space. So don't mistake that, okay, I got the read file entry over here and I will start analyzing the lines over here thinking that I am analyzing the malware process, but it's not. It's actually like the time might get wasted in analyzing the Windows non-malicious DLL file, that is kernel32.dll. So make sure that whenever there's a breakpoint, like suppose I am stopping over here that this function is going to be called, I don't start analyzing the below process over here, because always make sure that the module that is loaded now, that is showcasing now, is kernel32.dll, and it's not the brb.exe. Okay, so now I am inside the DLL but not in the process space. Okay, so never waste your time in kind of analyzing the codes over here. Always make sure that you are actually in the brb.exe space. Okay, so now if we see that this read file is about to be called, and the parameter that are going to be passed to this function are residing in the register value. Okay, and if I go again to the read file, I see that the handle is the first parameter that is getting passed and of that file. So let's see over here. So the handle over here will be the first register value. If you see, the handle is actually loaded in the RCX. You see the hex value BC. So BC is actually the what do you say, the handle value in hex of that file. So that file might have been opened somewhere, and kind of now kind of this process read file is trying to open that handle and trying to get the content of that file.
Pragyan,
Yes, yes, I did.
how to know that BC is a handle value?
Yeah, yes, yeah. So I will be showcasing that, like how can you know that, okay, what the handle value is related to that kind of. So there are several ways to kind of know, okay, if this handle is actually to that brb config.temp or some other file. So one of the easiest way, let's see if the handle tabs, so this handles tab, let's see if it shows me that. So the handle thing is actually blank. So any guess why it's there? It's totally blank.
No, no idea, Pragya.
Okay, so I'm just joking. So just do refresh and you will get, I think, the handle value. It's failing now, but let's see. So mostly what happens, like when you load the handle tab, so what happen thing is like you have to do a refresh and then kind of get the handle value. But I don't know why it's not working. So the other way that you can actually know, okay, that if that process uh, VC is actually linked to that kind of the VRB configure temp, you go to the process hacker and let's click on BRB border.txt. So it's running inside a debugger, but it will be showcasing as a process. So let's go to that. And now let's see if I can go to the handles tab over here. And let's see if I'm able to. So I'm sorting this out. And let's see if I can see over here the handle value. So normally I would have this. So the two ways that I was telling you guys, that first of all you have to see that handle value either in the handles tab of the x64 debugger, or the other way around is kind of see the handle value in this handles tab or in the process hacker. Okay, but kind of I am not saying that BRB config is still loaded in the process. Okay. So just give me a minute. I hope I hope this process was not running before I executed this. Just let me see. Environment, general. Okay, so it might happen that this BRB bot was running from like previously before I'm loading the kind of this process. So just let me make sure that thing is correct. Just a minute. Okay, so what I'll quickly do is kind of, I will again kind of, I will terminate this process, closing the debugger. But if you see that BRB bot.exe is even running now. The thing was like this BRB bot was running previously before I loaded this thing into debugger. I didn't make sure that it's not running. I should have terminated this before analyzing it in debugger. So what happened is like there is a functionality like it is called mutex. Okay, so what happens, like suppose the malware wants to, suppose there is a ransomware malware and it doesn't want uh, to kind of encrypt the files again in a system which has already been encrypted. Okay, so suppose the malware has executed first and it encrypted the file, and by mistake it got executed again. It doesn't want, it want to make sure that it doesn't again encrypt the already encrypted file. Okay, so what it does is like the malware actually does a any process actually what it does is actually use a functionality called mutex. Okay, so maybe the brbot.exe is actually kind of has set a mutex, and it is the new brbot.exe, if it is running, maybe it will not run properly and kind of do all the things that we were able to see previously. Okay, so what I will do is I will quickly terminate this process. Okay, and make sure that kind of it's not running again. So I'm not seeing the bibot.exe again. So let's load this debugger, this file again in the x64 debugger. So let's do that. Exe. And now quickly I will kind of set the bpx. So make sure the what you see, the case sensitive thing is there, like R is in caps, then F is in caps over here. So breakpoint already set. Okay, now let's run this process. Now it is over here, and let's go to the handle tabs. Now let's do the refresh. It's not still. Process hacker, BRE border.exe is running, and the handles tab. Yeah. So is it visible now? The BC handle, the value that I got from the register value.
Yeah, Pragya.
Yeah,
Yeah,
Pragyan, it is.
But how to know it is related to handle? I mean, we got the value. Oh, okay, okay, okay. I got
got
that.
it right. Got it
So
right.
the
Yeah.
the category is handle. So
Yes.
similarly, we can find other process as well, because when we are seeing read file, we are seeing handle and we are seeing other values as well, like LD. I mean, I couldn't recollect what are the other values. Apart from handle, there are other factors as
You mean like over here, these things?
in read file from MSDN.
Okay. So in read file, this thing is only the handle file, and we are actually interested on only knowing about this, because this LP buffer is something that is getting parsed. What it will do is like it will make a space for that. It is taking the maybe the taking the length of that file and kind of maybe allocating some space in the stack or heap memory to load the content of that file in the memory. Okay. So this
Okay,
all things, yeah. So this all thing we are not interested in. We are just interested in what file it is trying to open. So that information we actually will get from the handle information. Okay, H file.
okay,
And we know that this is the first parameter, and we know that RCX is the something holding that value. It's holding BC. So we
hmm,
are now pretty sure that this BC is actually a handle. And now we go to the process hacker, we go to the handles tab, and we search for this handle value BC. And we find that, okay, this BC is actually related to a file called vrbconfig.temp. Okay, is it clear
yeah,
now?
yeah, yeah.
Okay, great. Okay. So this is how we do, but thing is over here also these things should have worked, like doing a refresh and kind of it actually show you the handle file and all. Okay, so but this is the other way around. You just go to the process hacker and kind of get the handle value. Okay, so now what we will do is kind of
The
now,
good thing is we are having multiple ways. So, I mean,
yes,
somehow, if one thing is not working, we are
yeah,
relying on other things. So,
other
so
things, yes.
that is fine actually.
Yes, exactly. Yeah. So that actually happens a lot of time, even if you're like investigating any malware or doing any kind of network incident response, something like that. So always like you can't depend on one software, or maybe it hiding some entries, not parsing that properly. So always like try to see that with different tools and check like if any of the information is missing. So exactly, yeah, that is actually really helpful when we are doing any analysis thing. So there's another thing called call stack window over here. Okay, so let's see that. Okay, and now as you may guess, so thing is this call stack value is actually very useful when analyzing any malware. So what happened this is when I ran the malware, so whatever the functions that were called one by one, like suppose the function 1 got called, then function 2 got called, then 3, then 4. So this whole sequence will be recorded in this call stack. Okay, so maybe this was the last entry. So if you see the party is user, so user means the code, this offset is actually from the malware process, not from some DLL file. Okay, so thing is this BRB bots or something. So thing is this exe, this line from BRB bot.exe actually called the read file from kernel30.dll. So once that read file is over, I will this call stack will actually kind of transfer the control back to this. callee function. Okay, so this is a very useful thing. You can actually see like, okay, what was the functions calling sequence, so I can get the sequence from here. Okay, so I hope that's one of the things that will be very, very useful for to you guys when you're analyzing the code or any exe. Like you can just know the sequence flow. You don't know what's the function getting called one by one, so you can approach this call stack window and kind of see that. Okay, so now let's go further and kind of see what other things that x64 has to offer. Mm, okay, now go to the CPU window, and I am over here. So I am now pretty sure that read file actually kind of is uh, uh, kind of trying to read the brbconfig.temp file. So now I know what I want is actually I want to maybe set a breakpoint after this read file has been function has been completed, just to see if the decrypted content of the temp file is residing in the stack memory or the register value. Okay, so to do that, I have to again return to the user space, that is the kind of go to the brbconfig.temp.exe and maybe set a breakpoint again after this value. Okay, so to do that, what I will do is kind of go to CPU tab and debug. Just let me see the menu. I'm not getting that. So the menu that I am actually interested in is objective is actually to go to the caller of the read file, and I'm searching for the menu called run to user code option. So let's see that if it is there. Yeah. So if you see there, run to user code is there. Okay. So let's go to the user code, run to user code, and yeah. So what happened was that I am now in this path. If you see just below that read file, I am now in this line, test eax hyphen eax. Okay, so this was the line that will get executed once this read file like kind of was executed, and I will be returning to this line over here. So let's see how can I see the decrypted content of that file now. Okay, so just let me see that. Okay, guys, can you just give me 2 minutes now? We'll just take a 2 minute break.
Fine, brother.
Okay, guys. So now I'm in the. I hope I'm audible to everyone. Okay. Um, so now I will go and maybe I'll set a breakpoint over here too. Okay. And now I will let run the code. So I am now in the breakpoint over here, and it seems the read file code was executed. But let's see where I can see the. Okay, so thing is now this read file content read file function actually read the file. okay, the brb config.temp in a, so the file was actually in a encrypted data, was a encrypted data. And now I am over here, I have paused over here, and now let's see if there's any function that is trying to decrypt that file. So obviously this, the call to the decrypt menu, to decrypt function, will be below this read file. So let's just observe if I see any decrypt function over here. So I hope guys I am audible to all of you.
Yeah, Pragya.
Okay, great. Okay, so if you see just below this read file, I see a call to crypt decrypt function. Okay, so this is what, if you recall that when we ran the API monitor and we were like kind of monitoring the process variable.exe, we found that that function, this function was getting called, and this function was actually kind of returning the data in a decrypted format. Okay, so this is how we approach the same thing from a debugger perspective. We first set a breakpoint in read file, and once the read file thing was done, we went to the user code and set a breakpoint on the next instruction just below that read file, just to like not let this debugger run and kind of do the decryption, and we don't have to stop. We are not able to see that decryption in progress. So we pause the break, we set a breakpoint in test ex that is just below this read file entry, and then we see just going below that this function called decrypt, crypt decrypt was getting called. So again, like if you just want to know about the script decrypt, you can just go to crypt decrypt msdn. Okay, and now you can again see like, okay, what's the values that goes into this function. Okay, so H key something refers to handle to the key to use for decryption. So the key to that decryption file is actually residing in this script decrypt function, and this, and handle to the hash object if data. So something. So there are a lot of things that goes inside this function. Maybe the crypt, so that the encryption data might be loaded somewhere, and kind of the key to that to decrypt that thing, the key is getting passed to this function. Okay, so now let's see if we can kind of see that thing in action. Okay, so let's go set a bp call after the crypt decrypt function, and we will set a breakpoint over here too. So once this crypt decrypt function has been done, we will set again breakpoint over here, and now we are running the code, and we are now just after the crypt decrypt function. And what we see now, that the decrypted data is residing in the stack memory, if you see over here. And if you see in the RSP value, the stack pointer value, it's pointing to some offset in the stack. So if I go to this stack value DAFAB0, which is actually this DAFAB0, we see the decrypted data of that file is residing over here in the stack memory. Okay, so so I just want to stop and kind of take any questions from both of you. So any questions, guys?
No for me, Pragya.
So I hope the process that I followed to kind of decrypt this file is clear to both of you, right?
Yeah, again, it's clear.
Okay, great. So this is how, this is one of the way like we can kind of decrypt, we decrypted the content of that file. What we did was like, first we put a breakpoint on read file, and we made sure, okay, that this read file actually kind of trying to read our config.temp file. Okay, so because this read file might be in several instances, and maybe it is reading some different file, so we want to make sure that we are setting a breakpoint, we are on that read file, which is actually trying to read the file which is of our interest. Okay, and then when we did that, we went to the user space, and again then kind of put a breakpoint on test ex just below the read file, and then we just kind of went through and saw like if this encrypted data is getting decrypted anywhere, where we found that, okay, this code is actually calling the crypt decrypt function. And then what we did is like we set a breakpoint just below the script decrypt, just to let the crypt decrypt works on its own. So once that was done, we found that this RSP value is actually pointing to the stack where the decrypted content has been set up. So now what we see is like, we see something like URI ads.php. Maybe the malware is trying to connect to the attacker server and trying to access ads.php. And then there are something called related to some commands that we can see over here, like execute equal to something, file equal to something. Then we are making assumption that maybe the attacker is trying to send some command to this malware. And maybe like suppose suppose this malware process is running, and I want to download any additional malware to that system. So what I will do is like, maybe I will kind of uh, tell, okay, some file equal to some other path of some exe value, some malware process, and it will, maybe it will download that additional malware in that system. Or maybe suppose I want to run a server on the on the on the system. So maybe I will just send a command over here, execute equal to maybe nc hyphen l hyphen some port number. Maybe that server start running on that system. So that's way the attacker will make sure that even if the malware process is exiting, he has a backup to again connect to that kind of process. Okay, and even using this execute command, if he has the permission to execute any command, he can maybe do a lateral movement in the whole end network, maybe try to get the password of the admin account, and then see like what all drives are connected to that system, maybe try to again spread to that drive and do a lateral movement in the whole network. So using this functionality, he can achieve a lot of things just by kind of, if he has the power to kind of execute any command which he wants on the system. Okay, so now what we will do is we will stop analyzing this malware from the x64 debugger, and we will do something interesting, is that we will set up a fake TCP server. We will set up a fake ads.php, and we will let the malware kind of run and kind of connect to ads.php, and let's see like what the malware functionality changes when it is able to kind of touch this ads.php. Okay, so let's go to that. So now I'm closing this file. So let's close this x64 debugger, and always make sure that brb-config.temp is not running now. So let's go to that. So the brb-config.temp has exited because this brb-config.exe, brb-bot.exe was actually ran by the debugger. So as I exited the parent process, the child process also got called exited automatically. So now let's go to the so I just want to make sure that I am still connected to the Ramnex VM, the Ramnex Linux VM. So again, I am getting the same kind of issues over here. So let's go to the desktop, go to the Ramnex VM, and delete this log file. And now again, let's try executing this. Yep. So it's done. Okay. So I'll just make sure that I have a good connection with this Linux VM. So cmd, and let's do IP config. So it's 192.168.246.144. 144. So I'm just pinging that. Ping 192.168.246.144. 192.168.246.144. So yeah, I'm having a good connection to this system. I'll also see the other way around. I'll just see if I'm able to connect to 246.129. So ping 192. Ping 192.168.246.129. Yeah, I'm having a connection to the same system. So the connection is proper now. And now I will starting the web server on Ramnex VM. Okay. So to do that, I think we actually executed that thing last time. So let's see if I can still connect, if I can still uh, like have access to that server. Okay, so let's do 192.168.246.129, and yeah, so the process is running, so the server is running, and I'm able to get the I'm able to access that from the browser. Okay, and now what I will do is kind of um, so I hope you guys recall that to start the server on Ramnext, I actually executed the command httpd start, and to stop that you can just do httpd stop. Okay, so since the web server is already running, I'm not setting that again. And now what I will do is kind of, let's try to access ads.php. So it's telling 404 not found. So let's go back and try to set that up. Shift Control T and go to cd var cd www ls fake forms mistakes. So let's first of all check echo. I'm just creating a HTML file and just checking like if I'm able to access that from there. So HTML body hi slash body slash HTML, and just ping that in index.html ls and this cat. Okay, so this is set up over here. So I hope I will be able to kind of access that from here. Hi. So if you can see that I kind of made a index.html in kind of this folder. So if you see my current working directory over here is pwd. If I do so, if you see, to kind of suppose you ran a server and you want to kind of uh, make a survey web page to the client. So what you do is you need to go to this folder cd just give me a minute why this thing came. Okay, so you go to this folder path cd var www, and you can just make a file called index.html. I just wrote hi over here, and this page got served when I went to this directory. Okay, so in the same directory I will be kind of creating the ads.php. Okay, so let's do that. So echo and CX. So I will stop for a moment, and I will like to know like if there's any questions still now from both of you guys.
No for me.
Okay.
Okay, okay, great. So let's what I just want to showcase you that last time when we ran this process, we found okay that ads.php was there, and there were certain parameter like exec, something like this. Um, exec equal to just reverse of that cexe, something like that, and then something file equal to opposite of that. So what I'm going to do is I just want to check that if with this command it is actually trying to maybe kind of execute a command for me or not. Okay, so what I will do is kind of I will just do cexe, and I'll just try to open the notepad. So let's see where the notepad reside over here in my system. In any Windows system, I just want to see where the notepad.exe actually reside. So let's go to system 32. Okay, and notepad. So notepad actually reside in system 32 folder. Okay, so let's copy this. And what I want is like when the malware start executing the brb bot.exe, I want it to connect to ads.php, which I will make it over here. And then I am trying to give a command like open notepad for me, or any other kind of thing for me. Okay, so I will just do over here system32.notepad notepad.exe, and then I will like create a file with the name ads.php. Okay, now let's see ls. So there are two files. So the ads.php is now is existing in our fake web server. So if I just do cat, so the command, so in this ads.php there is only one line called as cexe and the path of the notepad. Okay, now let's see like if this malware is trying to kind of access this ads.php from a fake web server. Is it kind of executing this command for me in the Windows VM? Okay, so this is how the malware attacker might also had done is actually kind of he wrote the command name over here or the file name. I can also write I can remove notepad, I can write cmd.exe. That's how I can get a command prompt. Even I can supply some arguments to that. Okay, so just to confirm that, what I will do is I will again kind of run the malware, and let's see first if I can access ads.php from here from the browser. So I can like access that ads.php. And I just also want to recall tell you guys that last time we saw that there was a timer called sleep equal to 30,000. So thing is like the malware was actually, if you have seen, malware was trying to access ads.php at every 30 seconds. That we confirmed from the Wireshark. Okay, so now let's run the malware again and let's see if it is trying to kind of execute that thing. So so I've executed. So as soon as I executed this, so you see the notepad.exe got executed. Okay, so thing is it was able to link with the my web server. It got the command ads.php. It was like notepad.exe, and if I see the VRE bot is running now, and if I also see the notepad, so one more thing is that it every 30 seconds it will again try to connect to that ads php. So I think at next 30 seconds again a notepad will be executed. So if you see, two notepad had been executed now. Okay, so these are two notepad files, and let's see what's the process over here. Notepad, yeah. So notepad, if you see, if I just go to this process general, so if you see the current directory is brb bot, parent is brb bot.exe for this notepad. So now we are confirmed that this notepad was actually executed from the vrb bot.exe. That's how you actually see. So now if you see it, and now the 30 seconds are getting proper and three notepads are now executed. So what I will do is, let's, in the meanwhile on live, I will kind of try to change the thing to command.exe. Okay. Oh, okay. Cannot overwrite existing file. No problem. Okay. So what I will do is I will do rm ads.php. Yes. ls. It's not there, and I'll execute again. So let's see. Now list. So now till the time 4 notepad has been executed, and now let's see if it also execute for me the command.exe, the command prompt. So let's see over here. So let's close this, the old one, and just wait for some time. Yeah. So now if you see, the command.exe was also executed. And to confirm that, what I will do is I will go to this process, and you see the parent process is brb.exe. So the brb.exe will actually execute this command prompt. And even I can like maybe give some argument to this, like shut down, or maybe get the password of the system, do any other thing, encrypt the file. So all of the things I can do from here now. Okay. So this is, I hope now you guys got a really good idea like how we do analysis of BI, how we did the analysis of BI.exe. We kind of use some different debugger for that, x64 debugger. What are the features of x64 debugger? How we can like set up a fake web server, and kind of we did the code analysis. We tried to decrypt the file. We also kind of are seeing live that the process is actually executing the command prompt for us. Okay, so this is how actually the malware attacker was able to control the system. And I hope you guys got really kind of interested in seeing the whole analysis of brb.exe, and just want to know like if there's any questions now for this malware. Yeah.
No, Pragyan, the explanation was pretty much enough. Everything's pretty much
Okay,
clear.
okay, great, great. Okay. So now guys, I will be stopping the analysis of BRB config, BRB bot.exe, and we will be going to now to the module 2 of this course, where the 60% of the time is already is kind of will be invested in learning the assembly language. Okay. And apart from that, we will be also learning IDA Pro in a much more depth from the previous. So previously we got some test of how the assembly language looks like, how the IDA Pro looks like, and now we'll be investing time in learning about depth in depth about these tools and the assembly language. So let's stop this process from executing, otherwise it will bombard with command prompt. Terminate tree. Yeah, everything got over. Okay. So what I will do is now I will just take a 2 minutes break, and then we will start with IDA Pro 101. Okay, I hope that's fine.
Yeah. So we
Okay.
have the class till 11, right?
Okay, just let me see the time. It's
Yeah.
10:47. Yeah, so fine. We'll just kind of, if you want, just let me see. If you guys want, maybe we can start with IDA Pro from the next class, or is that fine to both of you?
Yeah.
Or okay, okay, then we will start a fresh class for this IDA Pro. We'll start with the IDA Pro 101, and we'll invest total time in learning about this IDA Pro, what this tool has to offer to us. Um,
Okay. And Pragyan, do you have any reference material or learning material related to assembly language that you can share with us?
okay, so thing is, I'll just share you the link on WhatsApp. So if you go to
Okay.
Security Tube website, they have assembly language primer over there for Windows, Linux, and all. Okay, so you can see that. Okay, but thing is,
Okay.
when I will be doing the course, I will be like kind of make sure that I give a very good understanding to you guys how the assembly languages are, what are the operands and all. So there won't be anything much needed to kind of read from some other course. But thing is, like, if you guys want to have a pre start yourself, so yeah, that security assembly language will be a good starting point for now. Yeah. Okay.
Okay, Pragyan. Thank
Yeah,
you.
so I'm stopping the share now, and I'm just closing